For decades, websites have been built using HTML, the standard markup language used to display documents in a web browser. Because HTML is designed for human eyes, it is highly visual. It is packed with code for navigation menus, styling blocks, interactive scripts, and tracking ads. But humans are no longer the only ones reading the internet. Autonomous AI agents are crawling websites at an accelerating rate to extract information. To a large language model, an AI system trained to understand and generate text, all of that visual HTML code is useless, expensive noise. It takes massive computing power to sift the actual sentences out from the formatting tags. This diagram illustrates an emerging alternative called Markdown. Markdown is a stripped-down, lightweight text format that removes the HTML boilerplate and leaves only the core structural data, like headings and paragraphs. When you convert a raw Amazon product page from HTML to Markdown, the volume of tokens, the basic units of text in AI processes, shrinks down from nearly 900,000 to fewer than 8,000. Providing this highly efficient format directly to bots seems logical, but executives from legacy search engines have pushed back hard. Representatives from Google and Microsoft have publicly condemned the practice of serving Markdown to AI agents. They call it a stupid idea, arguing it risks creating a shadow web where bots see different information than human users. This chart shows internal data from the web analytics firm Legible, and it reveals a disconnect between those public statements and actual bot behavior. When web servers offer both the heavy HTML and the clean Markdown, AI crawlers actively choose to ingest the Markdown 90. This discrepancy between how search companies talk and how their bots actually behave points to a high-stakes competition over how the web is built. To understand the conflict, we have to look at the three factions currently competing on the web: the legacy search giants, the new AI companies, and the independent web publishers who are caught in the middle. The new AI companies require massive streams of clean text to train their models and power real-time answers. Because Markdown strips away the visual clutter, it gives these startups the pure signal they need, without burning as much money on processing power. This visual shows the hidden economic advantage of the legacy search giants. Google spent years and billions of dollars building infrastructure capable of reading messy, complex web pages. Their systems can effortlessly render complex JavaScript, the programming language that makes web pages interactive, allowing them to extract text from almost anywhere. Newer AI bots lack this multi-billion-dollar rendering capability. When they hit a website built with heavy JavaScript, their extraction pipelines often jam and break, leaving them unable to read the page. If independent websites start converting their complex code into clean Markdown specifically for bots, Google's massive infrastructure advantage is instantly neutralized. The new AI competitors get the exact same high-quality data without having to build their own expensive rendering engines. The warnings from search executives about cloaking and shadow webs make more sense when viewed through this lens. Preserving the messy HTML web protects a technical advantage in data extraction. Independent publishers host the data that both sides want, but they are currently caught in the crossfire. AI agents aggressively scrape their articles and research to generate direct answers for users, often sending zero referral traffic in return. For decades, publishers relied on the robots.txt file, a simple text document placed on a server that politely asks specific bots not to crawl the site. But this is an honor system. Recent data shows that around 13% of AI crawlers now simply ignore these rules and take the data anyway. In response, publishers are turning to web application firewalls, or WAFs. A WAF is a security tool that inspects incoming web traffic and can forcefully block specific AI bots at the network level, regardless of whether the bot wants to respect the rules. This flowchart demonstrates the firewall's critical flaw. Publishers can block dedicated AI training bots. However, Google uses a single bot, Googlebot, for both standard search indexing and its AI features. If a publisher blocks Googlebot to stop AI scraping, they simultaneously remove their site from Google search. The threat of total invisibility forces the gate open. To find a sustainable path forward, publishers are testing pay-per-crawl protocols. Using specific HTTP response codes, servers can demand a microtransaction from the AI company before handing over the clean Markdown data. Publishers are no longer just passive sources of data. They are being forced to militarize their content architecture, implementing hard access controls to survive an economy built on mass extraction. This diagram shows an invisible routing system called content negotiation. It allows a single URL to deliver different file formats depending on the technical requirements of the visitor. Under this system, the URL stays exactly the same. When the server detects a human using a web browser, it routes them through the HTML door to deliver the visual page. When it detects an AI agent, it routes them through the Markdown door to deliver the raw text. And we know exactly how the crawlers respond to this architecture. Despite the resistance from legacy tech giants, internal data proves that when machines hit this fork in the road, they request the Markdown door 90% of the time. Technical capabilities are shifting faster than industry rules or legal frameworks. Website owners are currently navigating a divided ecosystem without a safety net, forced to make their own decisions about who gets access. To remain relevant in an environment of autonomous agents, building for human eyeballs is no longer enough. Data must be proactively architected for machine consumption, backed by technical boundaries that dictate exactly how it gets extracted.